Thank you for your patience, everyone. This is Manoj Kumar. Uh, we are from Unikaksha, and it is feeling great to welcome you all to today's Guru class, where we will be teaching. We'll be not teaching literally, but we will be showing you how to build your own machine learning model uh, to predict the fuel prices in India. We'll be taking a real life data set and we'll be building a model and we'll be working on a prediction model that actually is being implemented by all other data analysts, data science experts, and machine learning experts in different industries. And we will be simulating a similar model today. And it is great to have you all on this session. And we'll be having a lot more sessions in future. So let me just give you a brief introduction about our company and what we do best. And from there, I'll be handing over the session to Ms. Shreya, who is our expert trainer, and she'll be discussing with you how to build a model. I hope I'm audible, everyone.
Yes, sir.
Yes, sir.
Great. Manjit, please, I'll be presenting the PPT. You can admit the students once they're coming in.
Yes, sir. I'm doing it.
So, who we are? What is so special about Unikaksha? Why are we delivering these sessions to students? Who are looking at getting placed in their upcoming years. Why do we do this? So, the very important thing is we come from this background itself. We are the edtech brand of a company called Codechastra, which happens to be a software company. And ever since we have been venturing into this edtech sector, we have trained a lot of candidates who have whom we have recruited, and we always wanted this training to happen in a different way. Because there is a huge skill gap between what the institutions are teaching and what the industries. We since we are running our own industry, we know what the skill gap is, and this is where we come in, and we wanted to close this skill gap as much as possible, so that the students who are passing out in their in this 2022 or 2023 will be picking up, will be acquiring the right skills, so that they'll be getting placed in some good companies. uh, anyone can get a placement, right? These years, a lot of startups, especially after this pandemic, a lot of startups are there who are looking out for people who the websites are changing. Everything is becoming digitalized after this pandemic. We have been in a curfew. Learning became automated. Learning became digitalized. We are looking at lots and lots of platforms coming up every day, and still there is a huge gap between what the industries are expecting and what the institutions are teaching. To be more specific, uh, all of us know that websites are the most important element for any business. And how do we build websites? So we can use HTML, CSS, JavaScript to build a static website. Everyone knows it. But what the companies are expecting, they are expecting these websites to be very quick. They want these websites to cater to thousands of users at the same time. And they are more oriented towards securing their web application. When it comes to payments, when it comes to operations, when it comes to IPR, intellectual property rights, these companies are looking for developers who can build awesome web applications. And obviously we do the same. We are serving in around 20 plus countries across the globe, and we have been building awesome web applications. But the demands of the clients are always increasing, and we always have to look out for the new talent. And for whenever we go into these institutions to identify talent, there is no finding for the right talent. And what happens is we acquire them, we onboard them, and we train them for some time, and the students, they pick up the skills, they become qualified employees, skillful employees, and then they are deployed onto this project. This is a matter of 6 to 12 months, and we don't want this delay, because companies are evolving, clients are evolving, the projects, the solutions which everyone wants to look at is evolving, and the students still require a year's time to learn all these skills, or to acquire all these skills. We don't want that to happen. We want to close this gap, and that is when we started off this unique product, and we are proud winners of Amazon EdTech skill challenge, where Amazon conducts a unique competition for EdTech companies, and we have developed a product. That product we won back in 2020. And in the speaking about area of expertise, whatever the domain, you name it, whichever domain is the latest technology, latest trend in this industry, we are working on that industry as we speak. And our mission is to become the leading technology enabler for startups and high growth companies, and utilize them for the benefits of clients. So this is who we are. The Coach Astra is our software company, and that happens to be the parent company of Unikaksha, which happens to be the EdTech company. And through this EdTech company, we are trying to close this gap. For closing this gap, we have two programs. One is called as TechFit Icon program, and the other is TechFit Embark program, where in the Icon program, we select candidates from their colleges, or the final year students apply to our program, and we take them in. We give them a provisional offer letter. That is the most differentiating element about Unikaksha. Since we run our own company, we run our software company, we give a provisional offer letter as a job guarantee to students who are enrolling into our programs. And in this program, the students in their final semesters, they can enroll into this program. They can be part of Unikaksha and Coach Astra. They can, once they complete this training, they can undergo an internship period, and they can upgrade their provisional offer letter into an appointment order. This is the sort of job guarantee which we are giving. And the Embark program is slightly different, where we identify talent from right from the first year. So every semester there will be a small chunk of what the entire duration of this program covers. A small chunk, let's say in the first semester they study something, second semester they study something, and all through their semesters, their graduation, we teach everything in depth, and by that way we are making them who doesn't like to become a developer in a product based company, right? Who doesn't? I was a developer in a product based company once, so who doesn't like that? So we we want students to harvest their skills enough to become placed in a product based company. When I say product based company, everything is a product based company. Even CTS, TCS are product based companies, where they have different sections of businesses. So getting a job of 5 lakhs, 6 lakhs is not as easy as it sounds with the skill level, especially after this pandemic. And we want to help the students out, and that is why we have come up with a program like this, and to bring these what is required, to bring out the knowledge about what is required to the students. We are conducting these guru classes, and you will hopefully learn how to build a prediction model on your own today. And speaking about the TechFit Uniconnect Icon program, it is of 6 months duration, where it is split into two types, two modules actually. One is the technical module, and the other is the industry orientation program, where you will get to know how the actual industry works. So you will be a part of a team. That team will report to a team leader. The team leader will be reporting to a manager, manager to the CEO, and you will be receiving emails, you will be receiving deadlines, and within that deadline you will be completing your work. So that is what we call it as the industry orientation program. And we also have, as I told you already, we are already working together with 25 with a lot of companies in 25 different countries in the globe. And this entire program is going to be hands-on. We have our own platform where we'll be using to show you how to code, and we don't believe in TPTs. You cannot, teach yourself to swim. You cannot teach yourself to ride a bicycle. That is what we believe in, and that has been our entire inspiration to teach coding. So whatever we are teaching you, it will be completely based on exercises. There are 1,000+ exercises. It is not just with hello world and then connecting with the database. Everything comes with a scenario. We give you a scenario, we make you write the solution for that scenario. This is how you learn in a company, and that is how our programs will deliver. And by the end of this program, you either accept our offer letter, you upgrade your provisional offer letter to an appointment order, or you are most welcome to participate in our placement activities in other hiring partners or our partner companies, and you can get a job there as well. The minimum package which we are promising is 5 lakhs per annum. The entire training is vernacular. We understand that the language barrier should not be a reason for skill enhancement, and that is why we are offering this training in vernacular, and everything is learning by doing. So having said this, this is something which I wanted to convey, and I'm transferring this session over to Ms. Shreya to commence the actual section, and we'll be very happy to teach you how to build a model. And over to you, Ms. Shreya. Thank you.
Thank you, sir. So we start with what we want to learn today, predicting fuel prices in India. So sounds really interesting. We can predict something. So how we can predict something? These terms are very familiar to us nowadays: data science, machine learning, artificial intelligence, deep learning. But what these actually are and how we can use them in our everyday life. So that we are going to learn today, especially with the focus on predicting fuel prices in India. So let's start off with this. So what exactly is machine learning? So what we are going to do today is we are going to learn how to use machine learning techniques to do this prediction. Okay, so why we need to do this prediction, how we are going to do this, what we need to do. So all these things we are going to learn today. Obviously this 2 hours is not sufficient, but yes, I'll try to give you a glimpse of what we can do with the help of these machine learning techniques and how so much useful these are in our day-to-day life. So let's start off with today's session. I welcome you all, and let's start off. So what exactly is machine learning? The term suggests machine learning. So we make the machine learn something. Okay, so how we can use this in our day-to-day life, why it is useful? So it is useful in so many places. We have so many applications of machine learning. We can use machine learning in predicting something. We can predict the prices. We can predict which products are being brought by a customer together. We can predict things like weather. So many things we can predict with the help of these techniques. Now, how this thing came up, this thing, machine learning, this data science, all these things, how did they come up? They came up with the increase of data. Now, how we can predict something for the future is because we have a lot of data already in our hand. So as gradually with the technical revolution over the past 2-3 decades, companies started to have a lot of data in their stock, lots and lots of data. Even like today, it is being estimated that many millions of gigabytes of data is being generated every day all over the world. So with the help of so much of data, what we can do, like how so much data from the past, how so many records can help us to do something useful for the future. So that's the reason that machine learning came up, that we had so much data coming up. So with the help of this data, we can uncover some patterns and trends in the data, like how the things were going on in the past, So, and on the basis of that, we can try to guess something for the future. So we will learn some examples on this. We will understand how this thing happen. Like for example, in the previous picture, we were seeing that how, yeah, like see this, there's a store, right? For example, there's a store and the manager of the store wants to know that if a lady, she is buying bananas one day, then three other, it's her pattern that she will buy milk also, she will buy a loaf of bread also, she'll buy some carrots also, she'll buy butter also along with that. So because every time the billing is being done and it's being analyzed that she buys all these stuff together. So this becomes a pattern. Over like 3 years, this has been continuing, right? So this data has been accumulated in the management system of the store, right? So with the help of this data, it's being judged by the people who are managing the store that these items can be bought together normally by any customer. So what they will do is they will put together the items together. They will put all these items together so that anyone who is going to buy bananas will naturally think that, okay, let me buy some milk, let me buy bread also, let me buy some butter also, because they will be helpful. So naturally the customer will be inclined to buy all these other things also. So how this can be predicted is on the basis of the data which had been collected by the store over the past few years. Okay, so with the help of this data, they can know that what all items a customer is likely to buy together. So this will help to improve the decision. This will help to improve the decision for any business, like how a business can improve. Then we can also solve some complex problems with the help of machine learning. Some complex problems include, like, sometimes in medical field, they need to predict what a person may be suffering from, the disease, for like based on the symptoms. Like over the years, some symptoms, they are leading to a particular disease. A person has these symptoms, then it means that he has a particular disease. So like that, if in the future any new patient has all these symptoms, then he is most likely to have that disease. So such complex problems can be solved with the help of machine learning. So this is very, very trending topic these days, machine learning, and it opens a vast number of opportunities for all of us, that based on the previous data, we can get to know some trends, some patterns from the data. And with the help of those trends and patterns, we can find some solution for any problems which are not able to be solved otherwise. And we can also make some important business decisions based on that prediction. So let's move ahead. So yeah, we discussed that because of the increase of data which is being generated these days, we can build such predictive models which can analyze that complex data and find some useful insights and deliver some helpful results. So a lot of companies are using these techniques. So basically, what is machine learning? It is a subset of artificial intelligence, which provides the machine abilities to learn automatically and improve from experience. Basically, what we do is we provide the existing data to a machine, whatever data we have collected over the past, and we give that data to the machine. The machine will absorb that data, will try to learn from that data, and will give some output based on that existing data. It is much similar to how we learn, right? We learn from our past experiences, right? We learn that, okay, so many years, how we have to behave in a particular situation. We learn. For example, there's the classic example of a dog also, right? You ring the bell and the dog comes and you give him some food, right? So the dog will, every time you ring the bell, the dog will expect that you will give some food, right? Now you ring the bell and you don't have any food, but still the dog will expect some food and you will see the saliva going down from his mouth. So that is known as machine learning, that the dog has learned from his past experience that whenever the bell is being rang, then you will be giving him some food, right? So he will react as per his past experience. So that's something which is being done in a day-to-day basis also, right? So there are some terms which we need to know while we are trying to learn machine learning and while we are trying to implement machine learning for our today's problem. So we have machine learning algorithms. Basically, they are the set of rules and techniques which are used to learn the patterns from data. Okay. And we have a lot of algorithms in machine learning. For example, linear regression, clustering, classification, all these. And then model is basically the main aspect of machine learning, which is being built with the help of machine learning algorithm. Okay, the algorithm is used to build the model and we feed that data into the model. The data which had been collected in the past and which we want to use to predict something in the future. That data we are going to feed to the model. So algorithm is the set of rules, techniques, which will help us to uncover some patterns from the data. And model is the thing which is being trained with the help of the algorithm, and we will give the data to the model only. So next thing is the variables, predictor variables and response variable. So predictor variable is the data which is used to predict the output, which we are going to use to predict some output, and response variable is the output itself that we wanted to predict. So in our case, predictor variables and response variables, we are trying to predict fuel prices for India. So the response variable is the price, right? We are trying to predict the price. So the response variable is the price, and the predictor variable, we will see from the data that what are the variables which will help us in the prediction. Okay, so predictor variable means the variables which will help us, and response variable is the final output. Then we have training data set and testing data set. So training data set is basically the set of the predictor variables only, which will help us to predict the response variable. So machine learning model is being built with the help of training data. So training data basically is the data which we have collected over the years and which we are going to feed to the model to give some output. And testing data is a part of data which we are going to use to test our model. Okay, so first what we will do is we will try to build the model. We will send the training data with so model will learn. The machine, what it will do is it will learn from the training data set that, okay, like for example, from the customer example only, that, okay, for the past 3 years, these items have been brought together. So the machine will learn from this data. That is the training data. Then next time, what we will do is we will send some testing data that, okay, the customer has bought bananas. So will the customer buy other items also, which we had predicted? So that is the testing data. Testing data means that the data which we are going to use to test the model. So we have two data sets for machine learning: training data set and testing data set. Basically, testing data set will measure how accurately the model will be able to predict any outcome. So basically, the entire process is that we feed the machine some data, we give some data to the machine, then the machine will learn some patterns from the data, and based on the patterns, it will predict some future. Okay, so we will start. So this is the pictorial representation that we have some data. That data is being given to the machine. The machine is being trained, and based on the training, it will build some model. Basically, model means that it will use the existing data to analyze and represent the trends that, okay, this is the output and this will be this is the input, then this will be the output. Like for example, these many things, if the customer is buying these many things, then output is that the remaining things will be bought together. And based on the model, we will predict some output for future. So like for example, in our fuel prices data, then we will give the data, the machine will see that over the years, how the fuel prices were being increased, how they were changed over the years based on the place, based on the other parameters. Please mute yourself. Somebody has unmuted. Okay, so we will see the trend of how the fuel prices have changed over the years, and based on that trend, we will try to predict that what can be the fuel prices further on. Okay, so this is the process of machine learning. Please keep yourself muted. Okay, so this is the process of machine learning. First of all, we define the objective, what we want to do, what we want to predict, what decision we want to make. All these things we are going to define in the objective part. Okay, so in the objective part, right now, for example, we need to predict the fuel prices. So that is our objective, that we need to determine what will be the fuel price, say, over the next month. Okay, so first we are going to define the objective. Then based on that objective, we will try to gather some data. Okay, so what is our objective? Our objective is that we want to determine the fuel prices over the next month or over the next few months. Okay, so based on that information, now we know what we want to determine. So we are going to gather the data of fuel prices over the past, say, 10 years. 10 years or 5 years, as much as we can get the data, we will try to gather the data. We'll try to gather the data of prices, of the date, at which date, what was the price. Then, if possible, we can try to gather other information like what parameters are affecting the data. All these things we are going to gather in the data. Now, the data will have a lot of things which we don't need also, right? A lot of information will be there which we don't really need. And also there will be things which we are not able to process in the computer. So all these things we need to take care of that. So that part is known as cleaning and pre-processing. Okay, this preparing data and data exploration is part of cleaning and pre-processing. Cleaning means that we are going to clean the data, whatever things they are not required, or there may be some null values may be there, or some wrong values may be there, like somewhere the fuel prices may be by mistake, somebody must have put some negative sign in the fuel prices. So all these things need to be checked out, and the data needs to be made ready for the prediction part. So because when we are giving some data to the machine, then the machine will learn from it, right? Machine is not human that it will understand that, oh, it was a mistake of putting a negative sign. So that's why we need to clean the data, make it proper, make it appropriate for it to be sent to the computer, right? So that part is cleaning and pre-processing. Then once the data has been processed nicely and the data is ready, all the anomalies have been removed. So there may be some anomalies also that, like I said, some negative sign may be there or some zero value may be there. So these have been cleaned, removed. So then the next part is sending the data to the machine. Now using the data to discover some patterns, some trends, that how the fuel prices, they were increasing over the years, what were the parameters have been affecting the fuel prices, and based on that we will evaluate the model. And then the final part is that we will give some current data to the model, and based on that we will try to predict the prices. Okay, so this is the entire process of machine learning. So now why machine learning is so exciting and so interesting, and why it is giving so many opportunities these days to freshers to learn and to grow further, is because there are so many areas. Literally machine learning is there in almost every aspect today, in industry, in medical science, in education, in social media. Everywhere machine learning is being used. So like it's practically everywhere around us. We can see it everywhere. We have machines everywhere, and we have machines working for us. So these machines, they are working for us based on machine learning only. You have Alexa at home, you use Google Translate, Google speech to text conversion, and Siri we are using. So many things we are using which we don't know actually how things are working, but actually they are working with the help of machine learning only. So let's try to understand how machine learning is so exciting these days, and so many areas it can be used in. So for example, in social media, so one of the most common applications of social media is of machine learning is in social media. Like for example, when you open your Facebook, when you open your LinkedIn, so you have some suggestions for connecting with people. So how these suggestions are given to you with the help of machine learning, right? Because earlier you have searched some persons like this, or in your profile you have some information like where you worked or where you have studied at, and based on that information, Facebook or LinkedIn or all these platforms, they are giving you the profiles with similar information, right? So that's an example of machine learning. Then also it uses face recognition and image recognition to determine the face of the person. Okay, so it's useful. It's being used in social media. Then it's being used in product recommendation. So product recommendations, we have already discussed that. Suppose in a store, some products are recommended, and especially even in online, when we are doing some online shopping in e-commerce websites, there also, like suppose on Amazon, whenever you are searching for any item, whenever you are buying any item, then Amazon automatically gives you similar items, right? Customers who viewed this also brought, right? We have seen this. So how all these things are happening with the help of machine learning, because over the period of time, the system has learned that, okay, when a person buys this book on Amazon, then he might buy another similar book also. So these patterns are discovered, and with the help of that, such suggestions are provided to customers, so that the customers will be tempted, will be inclined to buy, and this improves the business of Amazon, right? So this helps to improve business, to make important business decisions. So this is very, very helpful, machine learning, in all the aspects these days. Okay, even in YouTube, like you have lot of video suggestions. So how such suggestions are coming, right? Because of machine learning only, that whatever videos you have been watching over the past few days, few months, similar videos, YouTube will suggest that please watch this. So this helps to improve the business, right? So then fraud detection. So fraud detection means if there is some inconsistency in the behavior of a customer, like suppose a credit card customer, there is some inconsistency in the behavior, so then there will be some fraud may be detected. Like for example, whenever you are trying to sign in into a new device, from a new device into your account, then there will be warning, right? Google will give you some warning that new sign in, like that. Or if there is some inconsistency in the credit card, like when you are trying to enter pin but you enter it wrongly multiple number of times, so like that, if there is some different things, some in the behavior, then the system will say that there is a chance of fraud. Okay, then virtual personal assistants, they are very, very helpful these days. We have Siri, Alexa, Cortana. So these personal assistants, how they are working? They're working with the help of speech recognition, speech to text conversion, natural language processing, text to speech conversion. So they are all, the basis of all these is machine learning only, that Alexa will learn, like whatever you tell. There has some algorithm has been implemented in Alexa, right? That when something has been told, then Alexa will respond accordingly. So this is how machines learn. From the previous data, they will learn, and based on that, they will respond to new data. Then another good example these days of machine learning is self-driving cars, Tesla. So it is becoming very popular nowadays, that how machine learning can be used in so many areas, like these self-driving cars. So how they are learning with the help of existing data, and based on that, they are performing, they are continuing their performance. So we have a lot of examples, other examples also for machine learning, like for example, when we are using cabs like Ola, Uber, all these things. So based on that also, based on the previous trip data, we have some estimated time arrival prediction, right? Whenever we are booking a cab. So it's based on the previous data again, that how much time had been taken previously to complete the trip. Based on that, the application predicts the future time as well. So all these are very exciting areas where we can use machine learning, and that's why we are trying to learn that how this machine learning we can use to take so many important business decisions. Okay, so now we come to how actually we are going to do machine learning. What are the types of machine learning? What are the algorithms? What are the models? All these things we are going to learn. So till now we have understood that machine learning is a very in thing, so many applications, so many important things we can do with the help of machine learning. So what are the types now? We have three main types: supervised, unsupervised, and reinforcement learning. So supervised, as the name suggests, that there is some supervision over the learning part. Some supervision means that we train the machine using data which has already some labels. Okay, so let's go over each of these one by one. So see this example. In the supervised learning, we have some data which has already the labels over there. So when the labels are there, then it is easy for the machine to know that, okay, this is Tom, this is Jerry, right? So we know that if this cat with the gray background like this, if it's there, then it's Tom. And if a small little thing with the brown color is this, then it means it's Jerry. So like that, it's easy for the machine to understand that, okay, this is Tom, this is Jerry. So it will classify the pictures based on the existing labels. We know the labels and we will classify based on that. So we will send this data to the machine. The data cleaning and everything will be done. Algorithm is applied and the output comes like this, that, okay, if the picture with this brown colored picture come, then it is put into class Jerry. And if this gray colored picture comes, then it is put into class Tom. So like that, supervised learning works, that the data or existing has some existing labels already present in the data, and the machine, based on that existing labels which has been already given to them, it will give the output of the new data. Then the next was unsupervised learning. So unsupervised learning means that we will just give some random data to the machine. We don't know that this gray colored picture is Tom, that this brown colored is Jerry. We are just giving this data over to the machine, and we just leave it to the machine, that it's the machine's headache. You decide whatever is Tom or whatever is Jerry. We are not giving any labels. So the machine, it becomes the machine's problem now to decide. But the machine doesn't know, right? Machine will not guess that, oh, its name is Tom, its name is Jerry, unless we tell. Previously in supervised learning, we were telling the machine that this is Tom, this is Jerry. So it was predicting based on that. But now it's not predicting based on that. So without any guidance, the machine will try to work on its own. So when this thing happens, then the machine will just put together the similar pictures and it will form clusters. So this is a machine learning algorithm which is known as clustering. Clustering means just putting together the similar kind of information together. Okay. And the previous thing which we had learned in supervised learning was classification. Classification means that it will classify the new data based on the existing labels, and it will put the data under the classes based on the previous classification. So this was a machine learning algorithm which is known as classification, and this was an algorithm which is known as clustering. Okay, and the third kind of machine learning technique was reinforcement learning. So that is actually an advanced machine learning, but it is a kind of learning in which, based on the data, the machine will try to learn, right? That's the core part of machine learning. And then what the machine learns, we will give some reward, we will give some points, we will tell the machine how it has learned, and based on that experience of machine learning, it will just try to improve itself. So that is a part of advanced machine learning. And so inside these supervised, unsupervised reinforcement, we have further classifications, we have further algorithms. In supervised, as we did learn just now, we have classification, and another example of supervised learning is regression. In unsupervised, we have clustering. So now we will learn two techniques of machine learning, which we are going to use for our today's discussion. We need to predict the fuel prices in India. So what I thought was that we can do regression and we can do neural networks, right? So regression analysis is a modeling technique which is used to study the relationship between a dependent and the independent variables. So what is a dependent and an independent variables? A dependent variable is that variable whose value is going to depend on some other variables, right? For example, right now, the fuel prices is the dependent variable whose value is going to depend on other variables like the date, the price of crude oil, the value of taxes, conversion of US dollars to rupees, and all these things. So all these are independent variables. Independent means that their value doesn't depend on any other third variable, right? Their value is independent. Like for example, date does not depend on any other thing. The place does not depend on any other thing. Conversion of US dollars to rupees does not depend on any other variable, right? So these are independent variables. And dependent variable here in our case is the fuel price, which is going to depend on the other independent variables. So regression means that we are going to try to analyze the relationship. Somebody is trying to write on the screen. Please don't do this. Please remove this. Thank you. Okay, so regression tries to find the relationship between the dependent and independent variables. So how they are going to relate to each other, that is the focus of regression. So regression is of three kinds: linear regression, polynomial regression, and one more. So we are going to discuss linear only, and we are going to implement the linear regression technique for our today's discussion. So linear regression is a supervised learning algorithm which is used to predict a continuous dependent variable based on the values of independent variable. So what is a continuous dependent variable? Continuous means that the value of that variable is continuous in nature. Continuous means that it's not like one day the fuel price is going to be 10 and the other day is going to be 25 and the next day is going to be 40. Right? It's not such a huge difference. What happens is, say today it's 10, 10 is actually very low. I should say 78 or 80. Right now it's shooting like anything. So suppose it's 80 one day, then the next day it's going to be 80.12 or it's going to be like 80.57 or 80.78 like that, right? It's not that one day it's 80 and the other day it's 88 like that. It's not such a big jump. So when the variables are continuously increasing or decreasing, means they are not so much, they are not having so much difference in their values. So that is a continuous variable. And we know what are the independent variables, the variables on which this dependent variable will depend. So yes, so yeah, continuous means that they are not so much discrete in nature. So we are going to implement this linear regression model today in our approach to predict the fuel prices. Okay, so linear regression will have will show a linear relationship between the independent and dependent variable. Okay, so this is an example of like trying to predict the stock prices with the help of time. So here time is the independent variable and stock price is a dependent variable. So stock prices, the value of stock price is going to depend on the time. And we are seeing that how the prices are varying. Okay, so you see these yellow dots are the actual prices which were varying as per the time. And because when we are trying to make the model based on the data, then that model is giving this relationship, which is a straight line. So if you see, almost like it's a linear relationship between stock price and time. Means if you try to connect the yellow dots together, apart from just 2-3 dots here and there, which are outliers, apart from that, we almost have a straight line, right? So this shows that the relationship between stock price and time is almost linear. We can call it a linear relationship because if you see the actual price, then it's and join the dots, then it's almost a line, a straight line. So the model will predict that it's a linear relationship. Okay, so that's a linear regression. We will implement all these things in today's session. Then the next method which I want to discuss is neural networks. So we have a lot of other methods also, like classification and clustering. And classification, as we have discussed, is a part of supervised learning. So these are all very important and popular techniques in machine learning. So it's good to learn, since we are doing this seminar on machine learning, that what exactly classification does, what exactly clustering does. So classification, what classification does is that it will classify the data into some labels, right? And clustering will cluster the data based on the similarities of the data points. Okay, so what more can be the example of classification is that we can classify some data based on the existing parameters. Okay, like we know the values of attributes of some variables, like for example, in real life, if we consider, then for example, the mail system, Google classifies a mail into spam, social, like that, right? So how this is being done, sometimes the classification is wrong also, but mostly if you see, it's accurate, right? The main emails, the important emails which are being sent directly to us, they are in the inbox, they are in the primary inbox, and whatever the social, the Twitter and Instagram, all such emails, they are in the social part, and the spam emails, they are in the spam. So like that, the mail system classifies based on the content, based on the sender, all these things, all these parameters. Based on all these parameters, the mail system will classify the mail into these different labels. Okay, then we have clustering. Clustering means that how we can cluster the data based on the existing data points. So clustering is unsupervised learning, means we can't classify into any labels, but we can just judge them. We can just judge the data based on the data points and put the data points which are similar to each other together. Okay, so another important technique, algorithm of machine learning is neural networks. So neural networks, they're also supervised learning, and as the word suggests, neural. So neural, what do we like infer from neural? The nervous system in our body, right? So how the nervous system in our body works? We have neurons which are connected to each other. They pass the information, the neurons pass the information from one neuron to another, the information is being passed. And based on that, the processing is being done in the brain, right? So like suppose I prick my finger, I put a pin on my finger, or I touch a hot pan with my finger, then the information goes to my brain. That's why I feel some pain in my finger, right? Otherwise, if there is some disconnection in the neurons, then I will not feel the pain, right? That's how anesthesia also works, that the disconnection is there, so we don't feel anything. So the information goes from one neuron to another. The whole body has a network of neurons with nerves connecting them, and the information is passed, and the information reaches the brain and tells that, oh, this something has pricked my finger, or my finger has touched some hot thing, right? So that's how the information passes and the processing is being done. So based on this pattern of human nervous system, the neural networks are being built. So they are a very, very important and popular machine learning algorithm. Okay, they process the information, and that information is passed from one neuron to another, and based on that, the output is being predicted. So neural networks are also known as artificial neural networks or simulated neural networks. So artificial, because they're artificial, they are not real, right? Real is in our body. So they consist of a layer of nodes. There is some input layer, and inside there are some multiple layers, which are used to process the data further and further to improve the prediction. So each node connects to another and has an associated weight and threshold. So there is some particular weight which is assigned to the node, and there is some threshold value. So what the weight does is that we multiply the weight with the input value and we send the output to the next node. So like that, we have the weights and the threshold value. And the threshold value basically checks that the output should be more than threshold. Means if the output is less than the threshold, then the data will not be passed. And if it is more than threshold, so the data will be passed. So threshold basically will tell the minimum value of output. So today we are just trying to give you a glimpse of how these things are working. So we will not go in detail. Basically, this is an example of neural network that we have some input at one side, we have some output at the other side, and in between we have some processing going on in multiple layers. Okay, so the processing is actually like regression only. We are trying to build a relationship between the input and the output parameters, and the output is being given to the next layer of neurons. So each node will have kind of its own regression model, and it will have how it will implement the regression model is based on the weights and based on the inputs. So based on the weights and inputs, it will send the output to the next node, and like that, it will help to determine the final output. The entire neural network will serve as an entire thing to give the final output. So multiple times the neurons will process the data, and it will, as a whole, the neural network will give some output, will give the value of the predicted variable. Okay, so now we shall start working with the with our data, and we will start with actually trying to predict the fuel prices with the help of existing data. So first of all, I would like to just show you the data, what data we have and how we are going to use that to predict our future fuel prices. So this is the data which is the data set which we are going to use. So the data consists of the city, consists of the date, the rate, and the state. Okay, so this is a simple data which we are going to use for today's session. Normally the data will have some more columns also, right? But since it's the first time that we all are going to learn machine learning, so just to give you a glimpse of how things are working, we are working like this with a simple data set. Okay, so we have some data of some cities. We have Hyderabad, we have Chennai, we have Delhi, so a lot of rows.
Hello, ma'am. Can you please share this data set with us?
I don't think I can do that and share the data set, because I just need to show you how things are working. Okay, so just try to follow like what I'm doing. Just you can try to follow. And okay, this is a simple data set. We have the cities, the date, the rate, and the state. So We will try.
You can share the data set with them, Shreya.
Sir, I can share. Okay.
Yes, please do share.
Okay, I will do that. Okay, I will share the data set with you all. And, okay, so here is the data set, and you can use it. Try to work with me. Okay. So next, what we are going to do is we are going to use Python to work on this data set and try to build a model and then try to use that model to predict the fuel prices. So I am using Colab, which is the online platform which we can use to work for Python and data science. You can use Jupyter Lab also. And because these platforms, they help us to work with large data sets. Okay, so I'm starting with a new notebook. So we'll be using Python, we'll be using some Python libraries to implement machine learning algorithms. So so from here, I'll be uploading the data set. Okay, so here I've uploaded the data set, and here we will start working with the code. Okay, so first of all, we need to import all the libraries which we are going to use to do all the processing part. We have to import the data, we have to import it in our code, we have to use that. So how all these things are going to happen? We need to import certain libraries of Python. So certain libraries, maybe you must have heard of these libraries. We need to import NumPy, we need to import pandas, we need to import matplotlib, we can do some plotting. So these are some important Python libraries which are used for data analysis. So NumPy, pandas, matplotlib is the library which we use to do some plotting, like we plot the data, we visualize it. So for that we use matplotlib. Pandas and NumPy is used to process the data. So pandas is used to convert the data to a data frame and do some processing on it. And similarly, NumPy also works on data as arrays, and it will help us to do some processing. Then we need to import the libraries as well, which we are going to use for doing the machine learning. We need to implement the machine learning algorithms, and we need to build the models to the prediction part. So for that, we will import the machine learning model. So scikit-learn is the Python library, which has the packages for building the machine learning model. So it is known as sklearn, and we will be importing since we want to do linear regression, we will be importing linear regression. Then we also need to do some pre-processing with the data, because if you see the data of this petrol.csv, we have dates, we have cities, states. So they are not numeric data. So with the help of this label encoder module, what we can do is we can convert this non-numeric data into numeric data. So that helps to build the model if the data is numeric. Even in neural networks, it is helpful if the data is numeric. So that's why we are importing this label encoder. So next, what we are importing is the train test split. So what we are doing is right now we are using one data set, that is petrol.csv, and we are going to split this existing data set into training and testing data. Okay, so you can have separate data sets also, which we can use for training. One data set can be used for training and the other data set can be used for testing the model. But right now we have, just to make things simpler, we are going to use one data set and we are going to split that into training and testing data. Okay, so what we do is we will write some code. So this is how the code works in whenever, like, we are working in Jupyter Lab or Colab, all these platforms, we have cells and we can write some code in the cell and run that, and we can write the next code. So that is helpful. Otherwise, if you write a lot of code together and then we run it, then there is some error in that, and then it becomes difficult to analyze and correct that. So I'll just do this and run it. Okay, so we are done. Now we move to the next cell and we start working. So the first thing which we need to do is we need to bring the code, bring the data into our code. Okay, so once we bring the data into our code, then only we can start with the pre-processing and we can start with the building of the model and the prediction part. So first we need to bring the data. So how we bring the data is using read.csv function of pandas. So we have imported pandas and we use the read.csv function and we write the name of the file. So file is already being imported, so there is no problem, and we can import. And then we can try to read, we will try to print the data set. So we will just print some few rows of the data set because it's a huge data set, and if you try to print the whole thing, then it becomes little messy. Okay, so we're just printing a few of the rows. You can even mention how many rows you want to print. If you want to print 5 rows, you can write that. Okay, so we have 5 because the first one is the name of the columns. So if you see, we have the city, date, rate, and state. Now based on that, we are going to do our analysis part. So now we need to understand what exactly we are going to do here. We are going to predict the rate based on city, date, and state. Okay, but what the aim is? See, firstly, we need to understand the objective. The objective of our uh, program is that we need to predict the fuel prices, right? So we need to predict the rates. Rates have been given. These are the existing rates, and we will be predicting the rates based on some other data also. Or in this data, what we are going to do is we are just splitting it into training and testing. So analyze the data. We need to analyze the data. What are the parameters in the data? What are the columns basically? So we have 4 columns: city, date, rate, and state. So what we are going to do is we are going to split this thing into input and output variables. If you remember from the PPT, we have predictor variables and we have the response variables, right? So we have some variables which are going to act as the predictor, and we have some variables which will be the response or the output or the thing that is going to be predicted. So the thing that is going to be predicted is the rate, right? That we have understood, and we just keep it separate. The remaining ones, that is city, date, and state, they are the variables which are going to help us in the prediction part. Okay. So what we are going to do is we need to split this into input and output. So let's call the input as X. And we slice out the data. This is known as slicing, and we slice out the data. So X is the input part. What are the input variables? City, date, and state. Right? That's the input part. Y is the output part. What is the output? Rate. Right? So we have split this into 2 data frames, X and Y. X is our input part, Y is our output part, right? Now, next thing what we need to do is we need to split the data into training and testing. Okay, so maybe I will add some comments here. Let's run this and okay. So when we see a tick mark here, it means that the code has been executed successfully. Next, we need to split the data set into training and testing data sets, right? So that we do with the help of train, test, split. So the code for this is so we use the train, test, split method, which we have already imported there on the top. We send the data sets, input and output, X, Y, and we also tell what is the test size, means what is the size of the test data set. Text size is equals to, so that could be anything, like that depends on you, like how much you want the part of the data set to act as training data set. Maybe you want 60-40, or you want maybe 2/3 of the data set to act as training data set, and you want 1/3 to act as the testing data set. So for example, I will just take 1/3 of the data set as the testing data set, and 2/3 let it be the training data set. So 1/3 means that 0.33 of the entire data set is going to act as the training data set, right? So we have split this data into training and testing data set, and whenever we want, we can just check out the, we can just read what how it looks like, how the data looks like. Okay, so if you see that we are getting a part of the training data set, and we can try to print. So if you see the numbers, see the serial numbers, and we don't have all the data sets, so it has randomly split the data into training and testing. Okay, so randomly 1/3 of the data has been sent in the training data set, and 2/3 has been sent in the testing data set. Now what we need to do is, next part is that we are going to use the machine learning algorithms to build the model and to predict the fuel prices. We can even check, we can check the count of I'm just trying to show you what all we can do with the data, what all information you can gather from the data. So we can check that in the training data set, we have different cities and how many values are there for each of the city. Okay, so Mumbai has 699 rows, Delhi has 687, like that. All of the different cities, they have these many number of rows. Okay, so now next thing is that we need to work with the data. So first of all, we can check if the data has any null value. Do we need to do some cleaning of the data? What the data has, like if the data is clean and perfect, then it's perfect for us. It's easy for us. We can just straight away move with doing the analysis part, with building the model and doing the prediction. But if the data has some null values, it has some unwanted columns, then we need to do the requisite pre-processing. So we will check the training data set once. We will check the information. We will use the info method, and we will check how the training data set looks like. Okay, so if you see that there are 3382 entries, and all of them are non-null. So it means we don't have any null value, and we don't need to like worry about the null values. Okay, so we can straight away move with the process, with the analysis. But again, we have to do some processing here, because if you see the data, it has cities, dates, states, right? The training data set and testing will have similar values, right? So what we need to do is we need to convert these non-numeric values into numeric values so that they can easily be worked with in the machine learning model, right? The model can learn easily from these. So for this, we are going to use the label encoder, which we had imported here. Okay, so we will be using the label encoder. Now what we will do is we will make a copy of the training data set, because we don't want to harm the the original training data set. We will make a copy of the training data set and we will try to do some appropriate processing on that by giving the labels, by giving the basically label encoder means that it will encode the labels. It will give some encoding to the non-numeric data. Like for example, we have 5 cities, Delhi, Bangalore, Chennai. So it will give some label like 0, 1, 2, 0 for Delhi, 1 for Chennai. Like that, it will give some encoding. Okay. So this is the use of label encoder, and we will create a copy of the training data set. So I'll call it xtrain1. Okay, so this xtrain1 is a copy of xtrain. That is a training data set, the input training data set. And then what I will do is now I will do some changes in this. So what I will use is I will use the transform method. So xtrain1 state okay. So now I'm using the xtrain dataset. Let's call it a simple name, so it becomes easy when we have to write it so many times. Right. So xtrain is the copy of the original x_train, and we are using this copy to do the transformation with the help of this label encoder method of the sklearn class. Now we will just do it for all the columns. So we have state, we have city, and we had date. So now let's try to see how this new training data set looks like. Okay, so now you see all the values of city, date, state, they have been converted into some encoding has been provided, right? They don't look like the city has the value of city were Bangalore and all these things, but it doesn't look like the same. Then state also doesn't look like the same. So Python has given some encoding to all the values. Okay, so now next what we need to do is we need to implement the model. We need to use the model. So we will be using the linear regression model first. Okay. We will fit the model. We will fit the data into this model. So now we need to send this X train and Y train. So X train, the new one which we have created, and Y train, which is the value of the fuel prices. So the Y train was Y underscore train. We can just check once again. Yes, Y underscore train is the training output data set, right? So we are sending the data. Now this is how we build the model. But first of all, we need to tell what model we are going to use. So the model is linear regression. Right now we are using linear regression, and we are going to fit the data into this model. So we are going to send the input and output data set, right? So input data set, which we have changed here, we have transformed it here, has been called as X train, and Y underscore train was the data, the output training data set, right? Let's keep on running as we move ahead. So it's printing linear regression. So linear regression model has been built, right? Now, what we are going to do is we are just going to try and see that what is the prediction value of the training data set only. So we can apply the prediction once with the help of the training data set before we send the testing data set. Okay, just we are going to predict and see that how good is the model, whether the model is actually accurately predicting the output, that is the fuel price, based on the input variables or not. So model.predict is the method which we are going to use to predict, and we are just going to predict with the help of the training data set only. Okay, so X train is our training data set. We're just going to predict with that. Okay. Next, we will check the score of our model. So this model dot score is a way to check the score of the model. So how we will check the score? With the help of this X train and Y train. Okay, we're going to check whether this model is how much correctly it is predicting the value of output with the help of X train. So it is going to check whether the output, the output is going to be predicted with the help of X train, right? And the actual output of X train is what? Y train only, because we are just taking the data, the existing data only. So we know what is the value of output. We know what is the value of the fuel prices for that particular day, for that particular city, right? But we are just checking if the model is actually predicting it correctly or not. So we are checking the model score based on X train and Y train only. Okay, so let's see how good our model is. So its score is not so good. It's just a 40.7% score. The reason the score is not so good is that the data is also like it's a simple data. Actually, it's a simple data that we don't have so many independent variables. The thing is that the more independent variables you have, the more iterations you have, the better the prediction becomes. Okay, but if you have lesser number of iterations, so we just did the model once and we did not split it. We can split it into multiple subsets also, but this is just an introductory session. It's just a glimpse of how we do this. So we can't do so much detailed analysis today. We can't do so much detailed prediction today. So that's why the score is looking like not so attractive. But yes, if we do a lot of iterations of prediction, then we can definitely get a much better score. So now we can also check the errors. So what we need to do is we will import metrics from sklearn, and we will try to check the error. You see, it's giving the suggestions also. So again, how these suggestions are working with the help of machine learning only. So now we will check what is the error. How we will check? Here, train underscore predict is the prediction, the output based on X train, and Y train was the original output, right? Y train is already in the training data set, which is telling the fuel prices for the training data set. And we are trying to predict again the fuel prices from the training data set in the train predict. So let's check how close both of these actually are. Okay, so absolute error is not so much. So means that more or less what we are predicting with the training data set and what the original training data set has the output was almost like they don't differ so much. We can also check the mean squared error. So we are having the error as 39.018. So all these parameters, they help us to determine how close our model is being working. Okay. So next we can also do this. So right now we just did it with the help of training data set. We can do it with the help of testing data set as well. So we can send the testing data . Okay, so there is a error here. So what is the error is that what we did here with the training data set, we need to do that with the testing data set as well. So that part we need to do first, that before we can use the testing data set to do the prediction, right? So you see, that's how an error will come, because it's non-numeric data set and it is not able to use that non-numeric data into for our prediction part. So the same thing what we have done with the training data set, we will do with the testing data as well. So this thing we could have done before also. Either ways, it's okay. Means you could have done that before, that splitting of training data into testing, the whole data set into training and testing data set, or otherwise you can do it here also. Let's see how the testing data looks like now. Right, so the testing data looks very similar to the training data set, means in the sense that it has been encoded with the help of this label encoder, right? So now we will do the prediction based on the testing data set also. Okay, and then we can follow the same steps which we have done here. So let's we can check the model score, we can check the error. Okay, oops, I checked with the training data set only. Right, so more or less we have the same score. Okay, so this is how we do the prediction. So let's do another model also. We have some time, we can try to learn 2 models at least today. So let's do the next one, that is neural networks. So I haven't imported the neural networks module. If you see, we have just imported linear regression, label encoder, train test split. So we now need to import the neural networks as well. We can give it some short name. Right. Then we will use the model. So let's use the regressor. MLP regressor model, which uses the regression technique for doing the neural network, for building the neural network model. So then we will have the so we are telling the number of iterations, maximum iterations can be 2000, and the number of states will be 5. So now let's build the model. Let's fit our data into the model. So again, this is our model, and we will fit like the same way we had done earlier, right? So we have the training and testing data set already with us. So we're just going to send the data sets inside. So we have the model ready. We have sent the training and training data set, and we have the model ready as MLP regressor, and with this number of iterations and these number of states. Next thing, we will be using this model to do the prediction part.
Shreya, I'll take 2 minutes of yours. I'm sharing a poll with the students, and we'll get the response, and then we'll proceed further, right?
So I'll stop sharing.
No. I'm just sharing the poll on Zoom itself.
Oh, okay.
So I request all the participants to answer these this poll which I have shared, and it would be greatly helpful to understand your perspectives. Thank you. %75% of the students have voted. I request the other 25% to complete the poll so that we can go ahead with the session. Thanks, Shreya. You can continue.
Right, sir. Yes, so we were continuing with the neural networks model. So we have built the model, we have sent the training data set into the model, and the model is ready. So next what we are going to do is we were about to check the model with the help of the training data set first, and then we will check with the help of the testing data set. So let's check the model, how it has performed for the training data set. Okay, so we have made the prediction. We have sent the training data set into the model, and then we can check the score of the model. Let's see if it is a little better than the linear regression. So let's send the X-train and Y-train and see the score. So it's a better score. We have a score of almost 72%. So neural networks, it's working better. So how it is working better is because we are using a number of iterations over here. In the linear regression model, we don't have this, we didn't implement this idea of having a lot of regressions, but right now, so if we use a lot of regressions, we again and again, a lot of iterations, we again and again try to predict, then the prediction will definitely improve. So we check the score, we check the, again, we can check the error. So how we check the error is with the help of what we have predicted. So what we have predicted is here in the predict underscore NN here, and the original output that was in Y underscore train. So we'll check the error. Right. We can check the mean squared error as well. So all these parameters show how good our model is. Okay, so you see the error is also less. Earlier our error was something higher. Yes, it was 39%, and now it's less. It's 18%. So now we can predict what we actually want to do. What we actually want to do is, now the training part is done, right? We have sent the training data set to the model, and even after sending, we just checked what is the output of the training data set. Means if we just send the training data set, the output of the input part, then will the output part also reflect the same? Okay, we checked that with the help of the training data set. Now comes the actual part. Now comes the actual prediction part, that we need to predict the petrol prices with the help of some new data. So we had sent the training data for the prediction, right? We have sent the training data set only to do the prediction part. And after that, we checked with the help of the training data set only whether the output part is the same as the prediction part. We just send the input part and we check with the output part, right? So now let's do the actual prediction. So right now for the actual prediction, we are using the testing data set. We are not, we can use some other data also, but since we wanted to simplify things to make you understand. So we split this original data set into two, training and testing. Now we will be using the testing data set and actually doing the prediction part, that what will be the fuel prices later on based on the testing data set. So let's do that. Let's send the testing data set. So I will just give it this a simple name, and we will predict the fuel prices by sending the testing data set into our neural networks. So we have X test, which we had already, here we had converted, we had done the encoding part. of the testing data set. So now we will send that and do the prediction. Okay, now what we can do is we will, again, you can do the same thing. You can check the score with the help of testing data set and all that. So let's quickly check the score also, and then we will visualize this prediction. So we have a better score again, almost 60%. Okay, now let's see how we can visualize this data. So I will save this data into a CSV file. So this prediction is in this data frame PR, and we will save it into a CSV file with the delimiter as a comma, because that's the delimiter in a CSV file, right? I hope you are aware of that. Okay, so we have saved this into a CSV file. So now just refresh it here, and you have this prices underscore predict.csv. Okay, so we have converted this prediction data set into a CSV file. Okay, now let's see how actually this looks like. Let's try to print this. Yeah, so you see this array is actually the predicted fuel prices, right? So it's looking like an array, and what we will try to do is we will try to put it together. We will try to put this predicted array of fuel prices with the remaining data set, the remaining testing data set, because this is the prediction for the testing data set, right? We have done the prediction for the testing data set. So let's try to put this together. So what we will do is, now we have X test. So let's visualize what is X test. Let's visualize the original one. Yes, this is our original test data, right? So what we will do is we'll try to collaborate these two things together, and so that we can have a look at it together. So what we will do is we need to put this column over here. So what we can do is, with we have the CSV file, we can read that again into a data frame. And we can concatenate these two. So we need to concatenate X underscore test and need to concatenate df1. So we will be using an inner join so that we don't have any null values, and the corresponding columns will be joined together. This prices underscore. Right. So now let's try to visualize our result. Right. So this is our final output, what we wanted to do today, that we are going to predict the prices for the corresponding city, date, and state. So we had the test data set here, and we had the predicted fuel prices, and we just put them together based on the inner join. Corresponding columns have been joined together, and this is the predicted fuel price. So you can check with the data set. You have the data set, you can check what actually was the price, the fuel price on this state and on this particular city, and you can check whether how much the prediction was true or not. If you see that more or less it will be true. So now we give it as an exercise to you to check out some recent data. Okay, check out the recent data of, like, say the month of March or February, and based on that data you can send that data instead of this testing data to our model. So we have learned how to build the model. So this model, same model you can use, and you can send that data of the city, the dates and rate. You can send that data as a testing data into this model, check the prediction. You can check the you can store your predicted fuel prices into a CSV file like this, and you can predict the fuel prices for the corresponding parameters of city, date, and state. So I hope that today's webinar had been useful for you all. You have learned the dynamics of machine learning, how useful it is to learn machine learning in today's date. It is like practically being used in so many areas, and such a useful and interesting thing it is to learn machine learning. You have a lot of models, but due to shortage of time we could do just 2 models. So you can use so many other models also to learn and to build your models based on the existing data and predict some interesting things, analyze trends, uncover some new insights. So that's it. Over to you, sir. You can say.
Shreya, there are some queries in the chat box. It would be really helpful if you can
Okay, sir.
answer them.
I will just take you. To predict stock price and fuel price, can we use the same programming method? Yes, you can use all these algorithms. So based on different scenarios, you will be choosing the algorithm that which one works the best. Then you have supervised and unsupervised. If you have the labels, then you can use supervised. You can use classification. If you don't have the labels, then you might prefer to use the unsupervised. So depending on the scenario, you will be using the different methods. Are we going to the theory part? We have done the analysis. Can you share this data set? I have done that. Data set I have sent. I have sent it on the chat. The data set, everyone is asking about the data set.
It would be really helpful if you can share the Python notebook data, the data file itself, right? You can share the link with everyone. you can give enough permissions to people who with the link who can open and see the notebook.
Okay, yeah, I will share, but everyone is asking about the data set. I don't know if maybe they have not received it or something.
No, you can share it again, right?
Okay, I'll share the data set as well as the code again.
Yep.
Aren't we going to visualize the data using matplot?
Yes, we can do that. Of course, you can plot the data. Let's do that. Let me share the link and then we can do the plotting also. Actually, our today's topic was that we wanted to predict the fuel prices, right? So I did not touch the plotting part because I wanted you to show how we can do the prediction. Okay, I think I had sent to okay, one particular person. I will share the data set again.
So for everyone's kind information, the session which you have attended is available on Unikaksha's YouTube channel. It is streamed live, and we'll be happy to share the datasets and Python notebook in the description of the video as well.
Okay, I've shared the data set again. And I'm sharing the link as well. Okay, I've shared the link. Maybe one of you can try if you are getting.
And to answer Bachtool Panji, yes, there will be a certificate provided to all participants who spend their quality time with us. You all will be receiving a certificate of appreciation over your email either tonight or on Monday.
So I think that's it. Most of them were asking for the data set and the code as well. And regarding the plots, if we have time, shall we do with the plots, sir, or like how?
Your call, Shreya, if you can show that next 5 minutes.
Okay, let's do a quick plotting thing.
Yep. Thanks.
Okay, so I'll share my screen again.
Shreya, Aman, a participant called Aman,
Okay.
is asking a question. How did we use qual qualitative data for regression?
Sorry, sir, I didn't, I'm not able to find the question.
So he has asked for at 7. He's been asking it for a long time, I guess. So anyways, yeah, he asked at 7:58. So how did we use qualitative data for regression is his question, and he has been requesting you to clear his doubt. But anyways, I guess it's time. You can use that.
Okay. How did we use qualitative? Yes, he's written quantitative, qualitative data for regression. We have tried to convert that into numeric data. We have given some encoding for the data, and that's how we have used it for regression. We are trying to find in regression what we do. We try to find the relationship between the variables, right? And how we can do that is if the data is numeric in nature, then it becomes easier for the model to be built. So we have converted, we have given some encoding for the data using the label encoder, and then we have used the regression part. And one person has asked, why is the column heading so weird in the result section? It's not weird. It's just a scientific notation. It was just a scientific notation of remember we have done in your school that like 7.5 into 10 to the power 1, like that. That's a scientific notation of presenting numbers. So that was a notation being used there. So you don't have to worry. You just check the column values that they are the actual fuel prices, and on the top it was just a scientific notation presented. Okay. And about the plots, we didn't really use the plots, but if you want to see, then we can quickly make one plot.
Your screen isn't shared yet.
Okay. Yes, I'm just sharing this. Yeah, so just we can make a simple plot with the help of matplotlib. Okay, let's try. We can try to, in our code, we have imported the matplotlib. We have to use the pyplot submodule of matplotlib, and we have imported as plt. So we can plot in the matplotlib. We have multiple plots, and we can plot the data as we have done it here. So first we need to send the x. So x could be our suppose we want to plot the rate with the dates. So right now actually it will be a messy plot because you have a lot of data rows. So let's print the rate. So x would be the date actually. First we give the x values and then we give the y values. So actually we have a lot of data and it's going to be a messy plot. So that's why I didn't really touch that part. But we need to, like, either we can just use some part of the data, or we can use a different plot. We can use a scatter plot, or we can use Seaborn also. We could have used there instead of Matplotlib to build a plot for this. So I think that for this session, it's enough, and maybe later we can do it, or you can try different plots on your own. You can try Seaborn for this. Okay, right, sir. Is that okay? Any other queries?
Thank you so much, Shreya. I believe the session was really interesting and fruitful for the students, especially the ones who are attending this data science for the first time. And I'm seeing a lot of positive feedback on the chat box as well. So, Michael Augustine, thank you for your honest feedback, and we'll really be back with the wonderful data science workshop again. And Siddhant, you have been really interactive. I just wanted to mention that. I appreciate all the participants. I thank everyone for your patience, and it has been really wonderful for delivering this session with you all guys. Thank you once again. Have a good weekend. Have a good night. Bye.